So these are 6-4 notes, and this is dealing with the greatest common factor, and we're going to be factoring out the greatest common factor with polynomials. So we're going to start with a warm-up of just finding the greatest common factor of just numbers. So if we remember, to find the greatest common factor, it's kind of like doing the opposite of the distributive property. When we are dealing with these polynomials. So before we multiplied polynomials, and this time we're kind of going the opposite of that, and you'll see that in a minute when we do an example. So we're first going to start with number 1, and that's finding the greatest common factor of 18 and 42. And so that's really just saying what is the highest or the biggest number that goes into both of those numbers. So to be able to do that, we just want to list our factors of 18 and 42. So I find it easy to start with like doing 1 and then go to the end and put 18, because 1 times 18 is 18. And then we can go on to 2. And then 2 times what is 18? 9. And then 3. And then 3 times 6 is 18. And then there's nothing in between that. 4 and 5 do not work. And so that is my full list of numbers. So 1 and then 42. And I do it this way because you want them to be in order. 2 and 21. 3 and 14. 6 and 7. So what is the biggest number that both of these share? So they both share 1 and 2 and 3 and 6. And they don't share any other numbers, so the largest one that they share is 6. So we can write that the greatest common factor equals 6. Okay, number 2, we want to find the greatest common factor of x to the 4th and x to the 10th. So we want to start by looking for the lowest exponent, so the smallest exponent number, and that's what we're going to be able to take out. So let's start with x to the 4th. And I'm going to write that out with how many x's that there are so we can see what they're sharing. So we have x, 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 and x. And then for x to the 10th, we have x, 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 x. I ran out of room there, but you get the idea. And now we're going to do the same thing like we did for number 1, and we're going to circle this time what they share since we're dealing with exponents. Here they share 4 x's. And as we can see when we're looking at this problem up here, our x to the 4th was our lowest, so our greatest common factor is x to the 4th. So we can take out that smallest one. Okay, now we're going to go on to example 1, and we're going to look at some polynomials. We're going to start with a monomial here, x to the 10th and 25. So what we want to know is what is the greatest common factor between these two terms. So if we're looking at 10x and 25, first think about what number we can take out between both of them. So what do they share? So what they share is 5. If you needed to write out the numbers again, you can, and then circle the largest one. But if you can just look at that and know the greatest common factor is going to be 5. Now, we dealt with the 10 and the 25. Now we want to deal with the x's. Well, there isn't an x on the 25, so our greatest common factor here is just 5. And the reason we kind of think of this as opposite of distributing, I'm going to show that here really quick, is if we were to take out that 5 from both of them, 10x divided by 5 would be 2x, and 25 divided by 5 would be 5. And so what we did here essentially was divide both of these terms by the largest number that we could, and then when we multiply this back out, we would get 10x plus 25. That's why it's kind of the opposite of distributing, because instead you're dividing all of the terms by the largest number, largest term possible. And we're going to get more into that on example 2, but I wanted you to kind of see a simple problem of why this is kind of the opposite of distributing. So let's go on to B. So again, sometimes it's just easy to look at this and see, which one's the smallest between both of them. And then you could just write that out. But if that's a little bit difficult for you to see, then you can just write out the x's that each of the problems have, and then the y's that each of the problem has. So here's our x's. So we're going to circle what they have in common. And that's how we get the x to the third. And then we'll do our y's. And they only share one y. So this is our greatest common factor. Okay, let's go on to C. So between 8 and 28, the largest thing that we can divide both of these by, the greatest common factor, is 4. Now don't get confused, because just because we have 28 and 8, 28 cannot be divided evenly by 8. So sometimes these ones get a little bit confusing because you think you know automatically, oh, I can just take 8 out. But it would actually be 4. And then we have an a squared and an a to the 5th, and the smaller one is a squared. All right, I want you to go ahead and try D on your own, and then I will write the answer. So for D, our greatest common factor is 4a to the 4th. And then, so that's for our a's, and then we have our b's. The smallest b is b. So I first took out the 12 and the 16 to get my 4, and then I did the smallest a, and then the smallest b. Okay, let's go on to example 2. So we're going to factor out the greatest common factor from each polynomial. So on number 1, they just asked us what the greatest common factor was. Now we're going to be doing this. We're going to be factoring it out. So we're actually going to take it out this time instead of just writing it. So we'll start with A, 20a plus 16. So I want to start with what is the biggest number, right? So we want to start with our constant number before we do the variables. So we can take out a 4. And then we can take out, we can't take out an a. So we would just write what each of these terms divided by our greatest common factor is. So 20a divided by our greatest common factor, and 16 divided by our greatest common factor. And you can check your answer by multiplying it out and actually doing the distributing. So we would get 20a plus 16, and that is correct. All right, let's look at B. So first, let's look for what is my greatest common factor. So again, let's start with the number. So we have 12, 8, and 6. Now we have to look for a greatest common factor between all three of these. So our greatest common factor between those three is 2. And then what is our lowest exponent here? X to the third. Now I want to divide each of these terms by that. So I'm going to write this on the outside, my greatest common factor on the outside, and I'm going to have my parentheses. So if I have 12x to the fifth, I want to divide that by 2x to the third, I will have 6x squared. If you remember our exponent rules, so I did 5 minus 3 to get my 2. And then I just divided the whole numbers. I divided 12 by 2 to get 6. And erase that other side there. So I think I'm going to need some more room here. Okay, now let's do 8x to the fourth divided by 2x to the third. So 8 divided by 2 first is 4. Now x to the fourth divided by x to the third, remember we want to subtract those exponents, so we're just going to have x to the first or just x. Then we have 6x cubed divided by 2x cubed, so 6 divided by 2 is 3, and there is a negative sign there, so don't forget that. And then x to the third minus x to the third, well, if you subtract the two 3's, you get 0. Anything to the 0 power is 1, so it would just end right here. And again, you can check it by multiplying each of these out, and you should get the same thing you started with. Okay, let's go on to our next one. So this one is a little bit tricky because in the beginning we have a negative sign right here. So we're going to want to factor that negative sign out. So the biggest number between -3, 12, and -21, our greatest common factor between those is -3. Then we want to look at our x's, and whichever one is the smallest. So that's our x to the first, and that's what we're going to divide each of our terms by. So I'm going to put my greatest common factor out on the outside again. We're going to start with our first one. So -3x to the fourth divided by -3x. -3 divided by -3. Remember your rules there, that's going to be a positive 1. And then x to the third. Remember, because this has an invisible 1 here. So 4 minus 1 for our exponents is 3. Kind of looks weird. Let me rewrite that. 3. There we go. And then we have our 12x cubed. Now here, it's important to remember that in our original one, we have a plus 12x cubed. A negative times a negative is going to get me a positive. And so that's why, for 1, that needs to be a negative. Also, when we take 12 divided by -3, we're going to get -4. So remember to include your signs there. And then we're going to have x squared, and then minus 7. Because we have -21, or sorry, plus 7. -21 divided by -3 is positive 7. And those are both x to the first, and so those would cancel out, become 1. And this is our final answer for this one. For these ones, I think it's pretty important to go ahead and try to multiply them out to make sure that you're getting the correct answer. Let's look at D. So you have 100a to the 7th times b to the 5th minus 150a to the 8th b to the 3rd. So this one is fairly long. It has bigger numbers than what we've been dealing with. So for this one, you might not know right off the bat what the greatest common factor is because these numbers are pretty large. But I know by looking at this that I can divide each of these by 10, right? So I know for sure I could take out a 10. And if I take out a 10, divide each one by 10, that's going to give me, just for the numbers in the front, that's going to give me a 10 and a 15. Well, now I also know that I can divide both of these by 5. And that's going to give me a 2 and a 3. So my greatest common factor is what I divided by. So I divided by 10 and I divided by 5. So 10 times 5 is 50. So my greatest common factor here is 50, just for the whole number there. So I'm going to have 50 in the beginning. And then, and then I want to take out my a's, so the smallest a is a to the 7th, the smallest b is b to the 3rd, and I want to divide each one by a to the 7th, b to the 3rd. So again, this is just like the subtracting. So for my first one, it already has a to the 7th, so I won't have anything there. I'll just have my 2b squared minus 3a, and then you can write to the first or just leave it. So then we have our last problem here. We want to figure out the area of the rectangle, so we need to factor this out. To find the area, we want to add these two. And we just want to factor. So our greatest common factor here is 3xy squared. 3 is my greatest common factor between 9 and 12. X is the smallest exponent, and y squared is the smallest exponent. So now I'm just going to divide each of these. Remember, you subtract the exponents when you divide. And then in the front here, that's my greatest common factor. Now, what we have here is a distribution problem. And so that is going to be what we're going to put on the sides of our rectangle. Because when we multiply these out, we should get what's inside the boxes. And that is all for these notes.